What's challenging, or what we know about multifamily buildings, is that the incentive for energy efficiency improvements are often split between the owner and then the resident who lives there. So it can make energy efficiency kind of a tangle.
We've been working in multifamily buildings for 30 years, and a lot of focus has been on boilers and doing tune-ups. Not very many people have really focused on ventilation systems. Building owners are, paying to heat and cool air, and they're kind of over-ventilating and paying for something they really don't need.
To quantify how much excessive ventilation energy usage could be reduced in multifamily buildings, starting in 2012, the Center for Energy and Environment conducted a unique and comprehensive study, identifying ventilation system issues and developing methods for screening and field testing. Ventilation in medium and large multifamily buildings accounts for 10 to 20% of the total energy use. This study focused on multifamily buildings with centrally exhausted ventilation systems.
What we're looking at is a two-step process. So the first part being a screening that would be normally done by the auditor, and then the second one being diagnostics, which kind of gets into more detailed measurements.
One of the great successes of the study is the development of the TrueFlow capture box, a new diagnostic tool that makes ventilation energy saving significantly more accessible.
This is essentially a new process to the auditing contracting world. There can be a lot to measure. There can be multiple 10, 20 even power roof ventilators providing the exhaust. So you have to measure, to get a good idea of what's going on in the building, all of them, or at least a good sample set. That can be really tedious, depending on what kind of method you're using to measure them. If you're spending an hour to 3 hours per fan, you're not going to get it done in a day or 2 days or 3 days. So we're using a familiar piece of equipment to most auditors, but in a totally different way.
The process for setting up and testing is simple. First, the energy auditor will measure the average base operation air pressure from inside the curb of the powered ventilator. Second, place the TrueFlow capture box over the running powered ventilator or fan, carefully making sure that the box covers the entire curb or is seated securely on the curb and sealed, and then remeasure the average pressure going into the fan. Third and last, we measure the average pressure across the plates on top of the TrueFlow capture box, which provides us with the airflow volume in the existing building conditions. With this information, simple calculations can be completed to identify potential energy savings in multifamily buildings.
It gives us something that doesn't require electricity, and it's fast. And I was looking at one of the buildings that frustrated me. It took us from October to January to finish the measurements, and we did the same number of fans, similar, in 3 hours. It was below zero in the wind. Yeah, it's not a vacation spot.
Based on our ventilation assessment, 58% of centrally exhausted multifamily buildings were able to reduce their energy usage. These energy improvements are saving building owners an average of $5,000 a year, and sometimes as much as $10,000.
Payback is always the thing that is the most motivating. We've been finding some really good paybacks. I see this changing, certainly my process as somebody who goes into buildings and does building assessments. It's a process that now I can incorporate into my building audits. It's expedient enough to where it's not going to add a lot of time to my building audits, but I can still characterize how their ventilation system is performing and give them an idea of how much energy savings they're going to see. Before, it wasn't cost effective to include that in our program, and now we can. That's a pretty big deal. There's a lot more energy savings we're going to be able to find in buildings by incorporating this into our assessment process.
It's cool.
This study was supported by a grant from the Minnesota Department of Commerce, Division of Energy Resources, through the Conservation Applied Research and Development Program, and co-funded by CEE in support of its nonprofit mission.